Okay, so I'm going to go ahead and go over your study guide with you guys here a little bit. I'm going to go ahead and work out the odd ones carefully, and then I'll just give the answers to the even ones to you, and you can work out the even ones on your own. Let's go ahead and begin here. So I want to solve for m. I have a quadratic equation here in standard form that's equal to 0. So first thing that we're going to do is we're going to set up our formula. B goes in the first two spots, A goes in the next spot as well as on the bottom, and then the last spot is for the C. And then we're going to simplify. So the first term becomes -7. 7 squared becomes 49. 4 times 10 is 40, times -2 is -80. And then on the bottom, 2 times 10 is 20. Double negatives become a positive, and now I have 129. And at this point, we try to break down our square root if we can. Okay, so I know that 3 is going to go in there 43 times. And 43 is a prime number, so I can't break that down anymore. So there's no pairs inside of this number, and therefore it's just going to stay just like that, and that's our answer. But you do need to know how to break them down. Now for number 2, I will do the first few steps because it is a little bit different than number 1. The problem with number 2 is the fact that it's not in standard form yet. We need to get all the terms on one side and have it be equal to 0. So to do that, the first thing we're going to do is we're going to add all the terms to the other side. So I'm going to add 11x to both sides, 11x squared I should say. And I'm going to minus the 3 on both sides. And I'll deal with the 2x in a second, but I get 6x squared plus 11 equals 2x. And the last thing I want to do is move this 2x over also. Now that 2x is not going to combine with anything because it's not like terms with anything. So now I've got 6x squared minus 2x plus 11 equals 0. And then from there, you're going to go ahead and do your quadratic formula. So, I guess I'll go ahead and work this one out too, because who knows, it might come out to be a little more complicated than the last one. So, negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Plug your numbers in. All right. So, double negatives here becomes positive. -2 squared is 4. And let's see. 24 times 11. It's a pretty big number. 24 times 11. I'm just going to use my calculator, and I get 264. And then 12 on the bottom. So we're going to subtract, and we get -260. And now we're going to simplify that square root. All right, so first of all, when you have a negative square root, the first thing you're going to do is you're going to put an I in the front and get rid of the negative on the inside. That's what we call an imaginary number when that happens. But we're still going to break it down as much as we can. 26 is 26 times 10. 26 is 13 times 2, and 10 is 2 times 5. So if I were to rewrite this square root as a product of its prime factors, it would look like this. And what we do is we look for pairs that are the same, and we can take a number out for every pair. And so what's left on the inside is a 13 and a 5, which is 5, carry the 1, I believe it's 65. All right, so I've simplified my square root, and I've gotten 2i square root 65. The last thing I want to do is I want to reduce if possible. Now you're only allowed to reduce if all three, it's got to be all three, can't be 2 of them, it's got to be all 3 numbers can be divided by something in common. And sure enough, all those numbers can be divided by 2. So if I divide all those numbers by 2, I would have the following. And just so you guys know, if you ever have a 1 on the bottom, or right here in front of the square root. You don't really need to write those. So this would be the simplest way to write the answer right there. And that's the end of number 2. Let's go ahead and take a look at the next problem. The next problem is changing a quadratic equation that's in standard form into vertex form. Now there's quite a few steps involved with that. Okay, so the first thing that we're going to do is we're going to add 31 to the other side, just like that. That's step 1. The next step that we're going to do is we're going to factor out the -5. Now when you take out that -5, you're going to be left with that. You basically just divide both of these numbers by -5, and the result is in parentheses there. Okay, now the next thing we're going to do is a really weird step. It's called completing the square. And what it is we're going to put a new number right there. And you get that new number by taking half of the 4, which is 2, -2 actually, and then you square it. So raise -2 to the second power, and that would be 4, and you're going to put that right there. That's a process called completing the square. However, the next step, we need to fix the balance because I just added a number on the left side of my equation, so I need to add a number on the right side to keep this equation balanced. So by putting a 4 in here, it's really being multiplied by 5. So I'm going to write multiply here because the first thing we want to do is multiply the 5, the -5 by the 4, and then we're going to add it to the other side. So what's -5 times 4? Well, it's -20. So I'm going to add a -20. So just to make it look prettier, I'm going to rewrite it up here really quick. When you add a negative number, that's just the same as subtracting. So I'm just going to change it to 31 minus 20. All right, the next step is to factor this trinomial. Now I gave you guys a shortcut instead of reviewing the old way. The shortcut is basically it's always going to look like this no matter what problem I give you. Maybe the x will be a different letter if you're working with a different letter, but I'm pretty sure it's just going to be an x. The only thing that really is ever going to change is the number you put right here. And that number will always be half of this number. And so half of -4 is -2. We're also going to combine that 31 and the 20 there to get 11. The last step is to go ahead and just move that 11 over to the other side by subtracting it on both sides. And we end up with that. So I have now successfully changed it from standard form to vertex form in that lengthy process. All right, so that's another question you guys can expect to see on your quiz. Now for the next question, for number 4, I'm not going to work it out, but I will show you guys the correct answer. If you want to know how to do it, I would say just check out the example before this one. And that's what you guys should be getting for number 4. Go ahead and move on to number 5. We're graphing in this problem. All right, so there are 3 important numbers we want to pay attention to. One of them is the number that's in front of the parentheses. Now in this case there isn't one, but if there is no number there, we can assume it's a 1. The other 2 numbers that are important is this 4 and this 1 here, okay? Now, if either one of these numbers are ever missing, then we can assume that they are 0. So just remember, if we have this little setup right here, no A means A equals 1. So if there's no A there, that means it equals 1. But if there's no H or K, that means they equal 0. So keep that in mind. Okay, but in this case, we have them all there. My A is 1, my H is 4, my K is 1. Now, these two numbers here, the 4 and the 1, give us the vertex. But we have to remember that when we write our vertex, the H value will be an opposite sign from what it is over here. So my vertex is -4, +1. The next thing is we look at the A value. Now the A value, if it is positive, gives you a happy face parabola. If it's negative, though, we get a sad face parabola. And that's pretty much all you really need to know. Now to give you a little bit more information, we could get a little more specific and say if the absolute value of A is less than 1, then that's going to make your parabola wider, but it's still right side up or upside down depending on whether that A is positive or negative. And in the same way, if your absolute value is greater than 1, it's going to actually make it skinnier. And the reason for that is because of what we learned in a few units ago called transformations with compressions and stretches. So when I look at this problem, I see it's a 1, and it's a positive 1. So that would be this one. It's a happy face parabola, normal size, with a vertex at -4, 1, and that's good enough for us there. Okay. So let's go ahead and take a look at the next one here. So once again, if you're looking at the video to get help on 6, I would say look back at number 5 because I explained how to do it here, there, but in this particular problem, I'm just going to give you the answer. And there you go. And I do believe that's it. So hopefully that's helpful to you guys, and hopefully you will on our quiz next week. All right, see you then. Bye.